It's no big deal. Okay. Now it's recording. Okay. Number two. Number two is similar. But it's more complicated because the polynomial for f of x equal 1/2 x to the 4th power parenthesis x to the 2nd power minus 5. Very, very similar, but you have extra factor que es x minus 2. I suppose that the degree of this polynomial is 7. 4 plus 2 plus 1. Degree 7. But it's not important for us now. We put it equal to 0. And you solve this equation. This 1/2 is totally useless. So now the first equation is x to the 4th power equals 0, que es equivalent to say que x equals 0, multiplicity 4, similar to the other part. The second is x squared minus 5, que I did before, is x is equal plus and minus radical 5. Actually, I put plus and minus, but the interpretation is radical 5 positive and radical 5 negative, no? Radical 5 negative, outside, of course, and the multiplicity is 1, and the multiplicity is 1. And remember, this is touched, and this is cross-cross. And the last one, the last factor is linear. This is 2. X equal positive 2, and multiplicity 1 again, cross it. Que es the option, I don't know exactly, I suppose que sí. Yes or no? 0 multiplicity 4, touch the axis. 2 multiplicity 1, cross the axis, radical 5 positive, multiplicity 1, cross the axis, and negative radical 5, cross the axis. Any question? I promise, in the test, one question like that. It's mandatory, it's easy. No? No question? Everyone follow me? Remember, I'm doing too fast because the review, no? I suppose that you know that part. You remember something, no? Erase, yes or no?
Yes.
No, wait.
Oh, I did I cannot undo. A ver si es posible. Undo. Control C. No, yes. Surprise. Undo.
Okay, give me one second.
No, take your time. You let me know.
Okay.
I want to go number 3. Number 3 is just copy, guy. This is different because the number 3, 4, 5, 6. I need to find x and y in a set. Okay. So I have f of x equal minus x squared x plus 9 and x squared minus 1. Mister, you copy?
Yes, I got it.
Okay, so I can erase, no?
Yes.
Let me try. I copy number 3, only copy, no solving. Okay, now let me try to see if it's possible or no. Select, yeah, I suppose que yes. Select. Moving. Okay. In this case, guys, remember to for finding y in a set, the formula is evaluate NC. For finding x in a set, O is different, is the function, the polynomial equals 0. And you convert like equation. In this case, no equation, it's just plugging in. Es obvio que es minus 0 square plus 0 plus 9 plus 0 square minus 1. Es obvio que I don't care. This is 9, this is negative 1, but multiplication I don't care because 0 square is 0, and 0 times any number is 0, and 0 have no sign. So I have no sense to talking about negative 0. 0 is 0. So the point is 0, 0. So this 0 is x, and this 0 is y. Clear? Number 3, no? We are doing. Now, the other is similar to the thing we are doing before, is, minus x squared time x plus 9, so you copy again. X squared minus 1 equal to 0. Entonces you separate. Zero factor property one more time. X squared equals 0. And you see, well, professor, what happened with this negative? This negative is not important. It's this negative working like a negative 1. And this is invisible. This is the invisible? No. It's a factor que never is 0. Entonces you apply the expression que contain variable equal to 0. Esta idea. X plus 9 equals 0. And x squared minus 1 equal to 0. In this case, x0, multiplicity 2. But not necessarily indicate multiplicity, no? No, not necessary. So this is 0, 0, 0, 0, 0. In this case, coincident with this. This 0 is x value, que es the value que you obtain, que es 0. And this 0 is the 0 que you suppose at the beginning, que es this. Okay, entonces x is equal to minus 9. The point are minus 1, 0. And finally, it's a quadratic equation. Si it's a quadratic equation, you move 1 to the other side, apply square on both sides. X is equal plus and minus 1. Actually, we have two more, 1, 0 and negative 1, 0. So in total. What is the collection of the X in a set? Is that one, and that one. 4. And what is the collection for the Y in a set? Only 1. Okay, by the way, it's coincident. Normally this happens when it's the origin. X in a set and Y in a set with this. Any question? Super cool.
So would the multiplicity for x squared minus 1 be 2? Or x equals minus 1? It would be plus multiplicity 2?
No, multiplicity 1 for each one separately. Multiplicity 1, and this is multiplicity 1 also. Only one value, minus 9 one time. So you list the Y in a set is, pero no la que voy a repair, list the zeros more properly. Would be 0, 0, 2 times multiplicity 2, comma 9, minus 9, sorry, comma 1, comma negative 1. In total, we have 1, 2, 3, 4, 5, 0, because the degree of this polynomial is 2 plus 2 is 4 plus 1 is 5. Degree 5, 5, 0. But you never indicate in this way. You indicate 0, 2 times. The multiplicity, remember, is the 2 times. And when this situation happens, multiplicity indicates us that the graph of the polynomial touched the x, the x-axis. This is clear or no? Yes or no? Okay. One fantastic way to copy faster is taking a screenshot. You don't know how you take a screenshot? May I erase or not yet?
Yes, can erase.
Okay. Number 3 I did, no? 4, 5, 6 is the same. Do you consider it necessary to do or no? What do you think? We are doing or no? 4, 5, and 6 is very, very similar to number 3. Okay, by the way, I don't say what's the answer to number 3, no? Es B, no? I guess so. X in a set, negative 9, negative 1, 0, and 1, and Y in a set 0. Do you consider it necessary to do or no? In order to save time. Yes or no?
No.
Me too. It's the same thing. Cool. Everyone is agreeing, guys. Si one student say no, you should do, professor. No. Okay, super. I like this class. Okay, we finished the first page. Let me move into the next page. ¿Qué es this? Okay, this is a little bit different, but it's easy. Is find the domain. And remember, we have rational function. And the rational function, the domain is all real number except the restriction, and the restriction lie in the denominator. So basically, you need to investigate if the rational function have vertical asymptote or holes. So in this case, super easy. I copy. Number 7. R rational is equal x plus 5 divided by x to the 4 power minus 49. Okay. So I need to avoid get the denominator expression to be 0. No? So you take x to the 4 power minus 49 equal to 0. And you solve in this equation. This equation is the degree 4. Now we suppose to have 4 solutions. But not 4 solutions necessarily is real. Okay, the fantastic way, easy way to solve this is by factorization. You realize that this is different of a square. And the square root this guy is x squared. And the square root this guy is 7. And plus and minus. Everyone follow me? And we have another different of a square. This is another different of a square. This no. This is the sum of the square. No factorial. This is prime expression. Entonces, when this situation happens, you need to understand that the prime expression, the solution have behind this a complex or imaginary. Okay, it's not necessary to find. Okay, it's living in another dimension and doesn't affect the domain. But one more time, you apply different of the square here. I don't copy this because I know that do not participate in the game. And this is XX. Oh no, because 7 is not a perfect square number. So the efficiency, in my opinion, is you copy like a quadratic equation. And you solve it using the square root method. The square root both sides. And this is x alone is equal plus or minus radical 7. And radical 7, you know, is a rational number. Okay, it's a rational number. Unfortunately, this answer is not here. It's not here, but I am sure it is the answer. The domain is all real number except all real number except. I remember all the time we solving this. You see in YouTube in the video is no radical 7 and no negative radical 7. I suppose the teacher doing this forgot radical 7 here. Radical 7. It's a let B. This is wrong, and this is all real number no. Be modified. Okay, make sense, right? Because it's 4 power. Now let me see in my paper. Yeah, it's the answer. I put B modified. B modified. Everyone follow me, guys, or no?
Yes.
Okay, let's do it number 8. And you let me know see we continue or not because it's similar. Okay, number 8. How? Number 8 is G, no? G, capital G, yeah, capital G of x equal x plus 4 over x squared plus 9. And remember, the only participation in this is the denominator. The numerator is completely irrelevant. It's not important to define the restrictions. Now you copy x squared plus 9. It's obvious that this expression is prime. But if you don't know or you don't remember, no problem. You try to solve it, you move 9 to the other side, apply square root, and immediately you understand that this is plus or minus 3i. Because the square root 9 is 3, but you have negative side, so we have imaginary. The conclusion is, remember, the assumption for finding the domain is, you suppose at the beginning that the domain is all real number. Except restriction. And the restriction, you find using the denominator equals 0, no? When there's division. But I try to do my best, but I obtain imaginary number or complex. When this situation happens, it's a frequent, not frequently, but happen. You need to understand that this restriction do not exist in the real field. So in algebra, when you try to find something that you don't know, and the answer is complex or imaginary, the interpretation is that these things you try to find do not exist. Si do not exist, entonces my domain obviously is whole real number. Make sense? Make sense or no?
Yes.
Number 9 and number 10 is very, very similar. Do you want I do or no? Thinking. Take your time. So you say yes, I do. So you say no, I don't.
Just don't do it.
No, don't. 9.
No, just go to the graph.
No. Go to the graph. Okay.
The bottom exercise.
Okay. Cool. Okay, the central idea is the graph. But you don't worry too much for the graphic because I appreciate so much that you are doing the graphic in Desmos. And you make a copy, a screenshot, and attach to the written test. But okay, let's do it by hand. At least the part gets possible by hand. And after we finish in Desmos. Okay, 11 is f of x is equal to x minus 1 over x. Wow, I don't understand anything. Because the professor explained me que rational function is the division to polynomial. Well, okay, let's do it. Find the least common denominator. Oh, no, condensing this in one common denominator, que is x. We have x squared minus 1. Okay, and remember the 7 step. Well, 7 no. We can do, for example. Yeah. Why not? We're doing, for example. What about the factorization? Well, the factorization is f of x is equal. This is a difference of a square. This is xx 1 plus or minus. This is a factorization, the top part, and the bottom stays. Okay, entonces y en z es evaluar en 0. Evaluar en 0, in my opinion, the easy way is plugging in here in the original. Doesn't matter, they are equivalent. Entonces es 0 minus 1 over 0. 1 over 0 to be undefined. That means that we have no y in z. And the 0, we have obviously vertical asymptote. Look at the denominator. It's obvious. But what about x and z? Well, x and z is easier because you take the numerator part and force it to be 0. So it's equivalent to say x plus 1 and x minus 1 is obvious que x is negative 1 using this factor. And using this factor, x equals positive 1. And the point are negative 1, 0 and 1, 0. Okay, this is my collection. So we have known y and z. No. X and z, yes, 2. Negative 1, 0 and positive 1, 0. What is the next step? Vertical asymptote. Vertical asymptote is super easy because you take the polynomial in the bottom, gets x, just x. Equal to 0. That's it. Now, horizontal or slant? What do you think? It's the complicated part. Tell me. Remember the degree analysis. What is the degree of the polynomial on the top? And what is the degree of the polynomial? Go ahead.
2.
2. And?
1.
When this situation happens, we have horizontal or slant? You don't remember?
No.
I recall. We have horizontal in 2 situations. Situation number 1, same degree, 2, 2, 1, 1, 3, 3. O, degree of the denominator bigger than degree of the numerator. It's obvious that the situation don't apply in this example because the degree of the top part is 2, is greater than 1. So actually we have slang. By the way, it's easy because you, one more time, you see the original. You don't need to find the slang because the slang is just X. Now, when you perform long division or synthetic division, you get X. So yes, we have a slang at Y equal X. That's it. That's it. Okay, so now with this information and one more information that you want, if you want complementary and the decimals and the way I want to show you now, you plot them. Let me try to. Is it question 11? No? Yeah. Look. Question 11. Switching to decimals. Do you see my decimals or no?
Yeah.
Yeah. Look at that. I copied the original. X minus 1 over X. I copy also the slang asymptote is Y equal X. I copy also the vertical asymptote is at X equals 0. Yeah, I copy different point. But I copy easy because I copy using function notation. So you define no Y equals, f of X. So if you want to find any complicated value using decimal like a calculator, and you plug it in using function notation. So now you can see clear like a water the graph of this. Okay, if you want to make a copy of this, okay, let me summarize. I investigate by hand that we have no y-intercept. It's obvious. The graph in blue color never touch the y-axis. The reason is clear because we have here in the y-axis we have a vertical asymptote. We have a slant asymptote. And we investigate in the piece of paper that the point is x-intercept was 1,0 and negative 1,0, this and this guy. And we have another complementary before and after this. Evaluate 2, evaluate 3, or evaluate 2, but easy, 2, fn2. And they are automatic decimal computer that. Now, if you want to present to me in the reading test, you click here, let me see here, ayuda, no? Here, share the graphic part. Okay, you export, bang, and you can modify different size, different whatever, and you download and attach to my paper. Cool? Everyone follow me? Everyone understand that part? Do you want? Because I can do more. Do you want I send the link connected with this script of the decimals?
Yes.
Entonces, when you receive that, don't hesitate to edit, to delete the thing you want, because it's a copy of my script. So I want to send, remember, I sent the video for today, I sent 2 more videos to complete the review, and I sent also this script. You click this and you see exactly the same that I have on my computer, but you can modify or delete or something, it's yours. Okay?
Question. On the exam, we
Go
put
ahead.
the number of the question that we graph and we just attach it to the file, right?
Yeah.
Okay.
Yeah. Don't waste the time with the graphic paper. No, hello. We are living the
No,
United
that's perfect.
Yeah. Okay, entonces, this was, what question was this? Number 11, no? 11. Let's move on to the 12. Okay, by the way, let me come back again to the whiteboard. It's obvious. Looking at the graphic is given. We see Let me share the screen. Whiteboard, no? Yeah. Look. Okay. Do you see my whiteboard or no?
Yes.
Not yet?
No, yeah, we can see.
Okay.
Well, at
Good.
least I see.
Good. Okay, let me try to find another page and you let me know. Of course, the test is no multiple choice. And the test we have no multiple choice. This is the paper, I suppose. I don't know. No, this is not the corresponding page. The corresponding page is that one. That one. That one. Okay, let me make it zoom to see more clear. No, no. I am crazy. It's not this. Okay, es this. I guess so. Yes. So this matching very, very well with this. Suppose that the test is multiple choice. Actually, no. I suppose that the answer of the 11 was C, no? Was C, right? So resemble a little bit with the thing we are doing. We are doing more elegant. We are doing more elegant. Any question, guy? Cool? Or no?
Yeah.
Okay. Let's move on to the 12. Remember the famous 7 step. Step number 1 is factorization. Okay, in this case, it's a difference of a square. Easy. It's x 4 plus or minus. Well, in this case, there are no factors that you cancel out. That's the reason we have no whole. Okay. Now the next step is y-intercept, que se evalúa en 0. Es obvio que es 0, ¿no? Because 0 over 0 squared minus 16 is 0 over minus 16 is 0. 0, 0. One more time is y-intercept and x-intercept, both. This is f of x equals 0. Actually, the only thing I care is the top part. To find the x-intercept, I take the polynomial in the top and enforce it to be 0. And this is coincidence, this idea with this idea. It's 0, 0. So we have only one. Okay, it's coincident, y-intercept and x-intercept. Okay, now vertical asymptote. Remember, you take q of x equals 0. Who is q? The polynomial in the denominator. Entonces, x squared minus 16 equals 0. X squared equal positive 16, square root both sides. X is equal plus or minus 4. So actually, we have 2 vertical asymptotes. If you want, no mandatory, but if you want to have roughly idea how look like our graphic, we have the famous all real number line. Cool. We have in the middle 0. This is infinity positive. This is infinity negative. 0, because 0 is important point in the graph because it's y-intercept and x-intercept. And also we have in positive 4, 1, 2, 3, 4. In negative 4, 1, 2, 3, 4. We have 2 vertical asymptotes. This is the situation that we have so far. See, I need to plug in a specific point, additional point. I select 5 or 6. I select 1. I select negative 1. I select negative 5. Not necessarily this. One guy inside is representative of the any interval. Okay, let's move on to the horizontal vertical. Horizontal slant, sorry. I want to copy one more time the function because I need to do the analysis of the degree. What do you think about degree? What is the degree of the polynomial at the top? What is the degree? 1. What is the degree polynomial in the bottom?
2.
2. When the situation happens with the degree of the polynomial at the bottom is greater than, we have horizontal or slant?
Line? No, wait, it's the horizontal.
Horizontal. So I repeat again, please recall this idea. Horizontal is more popular. Horizontal have in 2 cases, when the degree is the same, 2, 2, 3, 3, or in this special, when the degree of the denominator is bigger than 1 by 2. This degree 1, degree 2 is okay. Degree 1, degree 3 is okay. It's the same case. But this is special horizontal, right? We have slant only when the degree of the numerator top part is greater than 1, like in the previous example. Okay, entonces now es horizontal, for sure, 100%, and special at y0. When it's special, it's always y0. Okay. And the symmetry, well, the symmetry is obvious. Symmetry analysis is obvious. Okay, you replace x for negative x. And when you replace x for negative x in the original equation, I saw that the top part stays the same because negative inside the square becomes positive. But it's not. This stays the same. Entonces I can interpretation this negative, not necessarily here, sino in the front, que es equivalent, ¿no? That means que the symmetric of this function is odd. Remember the definition of the odd is when you make a reflection inside the parenthesis. I don't know why, but magically happen that this negative go outside. You see how this negative go outside here? How? Do you see or no?
Yeah.
Yeah.
Entonces it's easy. Suppose que I try to do by hand. I select some numbers in the right part. Suppose que I select 1 and 5. But the answer in -1 and -5 is the same, but opposite sign. So let's do it quickly because it's too easy. Suppose que I evalúe en 1. F en 1 is 1 over 1 squared minus 16. Entonces 1 over 1 minus 16, que es 15. Minus 1 over 15. So the famous point is the point 1, minus 1 over 15. Fabiana dice, profesor, tuve problemas para ingresar en la clase. Tiempo por mi cuenta de Skype. Okay, sorry. Let me anticipate something. We are doing the review. I predict we don't finish. However, I will send when the class is over the video of this plus 2 more videos of the other class in which I can finish the review. Also, I will send my script in Desmos, okay, you can see super clear any graph in this package, okay? Entonces now, the thing I try to explain is that when you evaluate in -1, you get the point -1, 1 over 15. You see it's the same value, but opposite side. That is the definition of that. Do you understand this idea or no?
Yes.
Cool. Let me show you quickly, of course, the graphic and Desmos. Do you see my Desmos? No, not yet.
We can see it.
Excellent. We can or we can't?
We see it.
Okay. My 12 problem is x over x squared minus 16. Okay, we discover in the piece of paper, okay, we have only one x and y in a set. We have 2 vertical axes and +4 and -4. You evaluate in different point. You see clear, guys, according to the shape of the graphic is typical odd function. Let me explain one more time. Look, suppose in 2 we have one number, okay, negative. By the way, a fraction was negative 1/15, no? Now in negative 2 we have exactly the same, but opposite sign. This is the idea of the odd function. Okay, it's another kind of symmetry, no? See, we have no symmetry, que es most popular. No symmetry. Symmetry is special. Maybe even or maybe odd. Okay, and we have one horizontal look. Asymptote at y equals 0, so perfectly coincident with the x-axis. And by the way, we have a crossing point and 0. I forgot that part, but it's obvious. It's elementary. It's no big deal. Cool, guys? Everyone follow me?
Sí.
Eso. Who said that? Walter.
Yo.
Who was you?
Anthony.
Andy. Okay. Okay, guys. So now let's move on to 13, no? 13 question. And total loss. 13 is that page or that page? I suppose it's that page, no? Let me see. No. Oh, no, let me see. I am lost, guys. Okay, what is that? What is the page? Oh, there you go. I found. It's that page. Yes, it's that page. Okay, that page. Let me make a zoom. 13. I want to go with 13. Look. 13 is f of x equal x squared plus x minus 6 divided by x squared minus x minus 2. Okay, what is...
Professor, your screen froze.
Oh, sorry. Let me try. Now, mister, you see that?
Yeah, I see it.
Cool. Thank you. Okay, so what is the first thing you should do always in the analysis of these functions? Huh?
You gotta find the...
Come on. Factorization. Es the keyword. Step 0, step 1 to start. Factorization. Factorization who? Factorization each polynomial, no? One by one. Factorization the top and factorization the bottom. But it's easy because that's trinomial. X, and the combination and the top, I suppose que es 3 and 2. Because 3 times 2 is 6. And somehow 3 minus 2 is 1. And the signs are positive 3 and negative 2. Everyone follow me?
Yes.
And the bottom, it's 2 and 1, I guess so, no? Because 2 times 1 is 2.
And
2 minus 1 is 1.
-2.
And negative 2 and positive 1.
And positive 1.
Eso, bueno. Everyone is agree with the idea?
Yes.
Okay, now important moment, crucial moment. You can see that the factor x minus 2 is cancelled. Yes or no? Now our expression look like that. X plus 3 cannot necessarily enclose in the parenthesis when there's only 1 divided by x plus 1. So you put a parenthesis, it's okay. No, it's no big deal. However, I detecting que at x equal positive 2, we have a whole. Yes or no? So the factor gets cancelled is the whole. So the whole is when you have 0 divided by 0. is very, very different to the asymptote, because the asymptote is 2 divided by 0, so any number, not 2 divided by 0. This is the asymptote. This is the vertical asymptote, but this is the whole situation. Okay? Guy, do you follow me or no?
Yes.
Okay. So the whole, you consider in the last moment, like one, you know, when you are doing the graph, I don't know, in this moment, not clear, you put the hole here in the position 2, x equal 2. It's the only thing you should do. Okay, so let's follow in the idea. We continue. It's the same routine. Y and Z. Es obvio que es evaluar en 0. Si you evaluate en 0, stay alive. 6, minus 6 in the top, and minus 2 in the bottom. Okay, 3. And the point is 0,3. Cool? It's a Y and Z. And the X and Z, you take the polynomial, but the polynomial stay alive for this. So it's x plus 3 equals 0, then x equals minus 3. And the 0 is the point, minus 3, 0. This is the x. Okay, cool. Now vertical asymptote. Well, vertical asymptote, we have only one. S cube x equals 0. Who is q? Is x plus 1 equals 0. Therefore, at x equals minus 1, we have the famous vertical asymptote. Of course, we plot in decimal, no? Like a dotted line in black color. The thing you don't understand or you don't remember very well, the idea of the horizontal slant. What do you think in this specific example?
Horizontal.
Yes, you're right, mister. At what value? At
Y equals 1.
Y equal 1. You're right. How do you know that 1? Where come from that 1? Bueno, es the division, this coefficient divided by this coefficient. Or this coefficient divided by this coefficient. So you take the leading coefficient in any polynomial and divide. And in this case, no symmetry. I don't want to waste the time with this. No symmetry. I want to show you quickly the graph in decimals of the question 13. Do you see this one? Or no? Or yes or no?
Yes.
Question 13. Look at that. Bam. Okay. You can see we have one vertical asymptote and negative 1. We have one horizontal asymptote and 1. We have a hole. Look at the hole. Let me make it zoom. Do you see the hole? How do you know the position for the hole? It's easy. Because we are doing the graphic of the function after the simplification. I put different color. When I do the graph of this, I put a red color, and you see that the graph of this is equivalent almost 100% with the original graph. Look, let me flash it. The original is blue. But what is the only difference? The hole. This have no hole because I cancel out the hole. Clear? Clear or no?
Yes.
Okay. You consider it necessary to do 14 or no? Honesty. You say yes, yes, I do.
I don't think so.
Okay. No? Don't think so?
Just do it.
Just do
I'll
it.
say yes.
Okay. Chew on.
Please.
I always hear the lady. The woman is wise. Okay. Do you see whiteboard?
Yes.
Let me erase something because I'm totally lost. Let me erase that part at least. Okay, boom. Okay, this is we moving to question 14, no? 14. Oh, let me see. 14.
14. Because
Okay, I got it. It's 14. Make it soon. 14 is look like complicated. Is f of x is equal x squared plus 5x plus 6 divided by x minus 3 squared. Okay, entonces as all we have, and what should I do? What should I do? What should I do? Factorization, no? Yeah, let's do it. The factorization and the top is 2 parentheses xx.
So x plus
3.
2x plus 3.
Cool. 3 and 2 positive both, no? And
Yes.
the bottom one at the bottom actually is factorization already, no? If you want to see more clear, you put x minus 3 times xl. But no factor is cancel out. Stay the same. Yes or no? I like personally that way. You keep this like a square. Okay. Let's do it now. The traditional systematic step. Y in a set, x in a set, and so on. Y in a set is evaluate the function in 0. Evaluate the function in 0 is 6. And the top 0, 0, 0, and 9. And the bottom, yes or no? Because 0 minus 3 is minus 3. Minus 3 squared is positive 9. You reduce the lowest term, of course, divided by 3 is 2 thirds. But the famous point is the point 0, 2 thirds. Okay, yes. Okay, now the x intercept es obvio que es the 0 of the top part. Que super, o sea, you enforce the function equal to 0, que es equivalent to, see this guy is 0, I don't care the bottom part. The important part is the top part. Es obvio que the solution for this equation is negative 3 and negative 2. Therefore, si you express it like the ordered pair is minus 3, 0, comma, minus 2, 0. This is my collection of the x in a set. Okay. One more. Beric acid. What do you think, beric acid? We have or no? What should I do to find beric acid? Always, it's the same. What is the formula? Do you remember that formula or no?
Yeah.
Yeah. You take q, but q is x minus 3 squared equals 0. Actually, it's x equals 3. No? What are the only differences? When the factor is quadratic, I suppose, using my imagination, look, this is all real number line. This is positive infinity. This is negative infinity. And we have here important amount 0. Let me put 0 as the reference. Negative 2 and negative 3. Negative 1, negative 2, and negative 3. So we have 1 point here, que es negative 2, and 1 point here, que es negative 3. But we have another point important, que es positive 3. 1, 2, and 3. And positive 3, we have the baric acid. And this baric acid, remember we have 4 kinds of behavior. But in this case, I suppose they look like that. Swing, swing. Why like that? Because it's a square. And a square is so when you square, always become positive. And when it becomes positive, is this. No, it's like another asymptom, you know, que es another behavior, like that, no? And it's when the, suppose que this number is 3, no? But entonces no, This is when it's linear, 1 here, but when it's quadratic, make sense, right? Make sense or no?
Mm-hmm.
Okay. And what about horizontal or slant? What do you think? We have horizontal or we have slant?
Slant.
Slant. No, you don't remember very well this. I repeat. I suppose I repeat today 4 times. Guys, try to recall. We have slant. You have okay. Okay. You have suppose n numerator, d denominator, and suppose letter d is degree. When the degree of the numerator is equal degree of the denominator, yes, we have horizontal. Or y equal the division, the leading coefficients, you know. Slant we have when the degree of the numerator plus 1 is equal the degree of the denominator. So suppose that the degree of the denominator is 2 and the degree of the numerator is 3. Yes, we have a slant. Otherwise, no. So what is the degree of our famous numerator? Degree. What is the degree of this guy? And what is the degree
3.
of this guy? No.
I mean,
3.
2 and...
Degree is
Yeah.
exponent. Okay. Then what is the degree? 2 or 3?
I said 3.
No, it's 2.
You don't...
Okay.
Oh, yeah, I
Definition.
forgot. You don't add them.
Please. No, easy. You're a student. You make a mistake. I am a teacher. I need to teach you. Okay. Degree, by definition, is the exponent, the higher exponent in the polynomial. Es obvio que es 2. Entonces, en the bottom, what is the degree? Es 2 also. Es 2 also. It's confusing. Yeah, well, because this is exponent. So you, for example, you expand this, you apply FOIL. X minus 3 times E cell. FOIL. X times X, X squared. X times minus 3, minus 3X. Minus 3 times X, minus 3X. Again. And minus 3 times minus 3 is positive now. And we combine later, as always, happen in FOIL. Minus 6X plus 9. Okay, so I mentally, I can erase that part. Look, this is equivalent to say x squared minus 6x plus 9. And one more time happen, que the degree is 2. Do you see or no?
Yeah.
Cool. Now, when you have the same degree, what kind of the asymptote we have? Horizontal or plan?
Horizontal.
At what value? Y equals something?
1.
1, que es the division, this number divided by this number. Excellent. Okay. Now let me show you the graph in decimal, and we finish the graph, no? It's the last one. Yes, it's the last one. We're doing well today. Okay. So decimals show you switching to decimals now. Okay, I try. Do you see or no? Question 14. No? Do you see? Wow, what the hell?
Question.
Look. It's exactly we predict. Remember, 2 points en -2 y en -3, que es el X in a set. We predict Y in a set, que es el point 0,2 que 2 en décima es 0.6 repeated. We predict that we have a vertical asymptote at positive 3. And the behavior both branch of the curve is upward. Bang! And also we predict that the horizontal asymptote exists at y equal 1. Let me show you. This line is y equal 1, and this is horizontal asymptote in both directions, positive infinity and negative infinity. Yeah, I forgot the crossing point. Okay, this. Okay, this is not important. Not too important. Cool.
Yeah.
Any question? Any question?
Professor.
Uh-huh.
I was asking, can you go to number 17 on the review?
Okay. Pero now we are doing now 15, no? 15, 16, no?
Okay, I didn't know we were doing about order. I thought we was like whichever one we needed help more.
No, it's okay. I have a paper here. So now we are doing 14, now 15. 15, 16 is super important.
Okay.
It's the famous inequality. Walter, do you see whiteboard?
Yes, I see it.
Look at that. That page we are doing. We are doing 15 first. 15 is, I want to copy. 15. It's inequality que es x to the 4th power less than 9x squared. Remember, my recommendation to solving any polynomial inequality, you have to manipulate the inequality and put everything in the left-hand side. And the reason is because right-hand side must be 0. Must be 0. Do you remember this idea? And it's 0 because in the last moment, we compare if it's positive or negative to be true or to be false. So the level of comparison is 0. You need this 0. This is the most important thing. I saw a lot of people try to solving and not including this idea. Now factorization. You focus it in the expression on the left-hand side, and we are doing our best in the factorization. In this case, the GCF, greater common factor, is x squared. I factor out, and we have x squared minus 9. Less than 0. Yeah, I finished, no? Why not? Because I continue factorization because I saw here a difference of a square. X squared, 2 parentheses now, is x 3 plus or minus. Cool. And this is my expression. Okay, focus my attention 100%. Okay? And this is equivalent, exactly the same, equivalent to the original. But the original is ugly, nobody understands very well. However, this is more clear. Okay, so I have a question. I remember I explained in the lecture, when you have a factor that contains even exponent, we can delete partial or delete totally. Do you remember that or not?
Yes.
Yeah.
In that case, I delete partial or I delete totally?
Totally.
Totally, no. You delete totally when you have equal sign. But when you have no equal sign, you delete. I agree with you, but delete partial. What mean to be partial? Okay, I convert this inequality to this inequality. X plus 3, x minus 3, less than 0. Cool. I delete mentally this, but you include, okay, in 0 we have a whole. So when you write the final answer in the solution, you keep in mind that 0 don't belong to the solution. But it's easy for me solving this new inequality under the consideration that 0 don't belong to the solution. That's it. Let's do it. So now you convert the inequality to equation. Super easy. you can find that the solution is -3 and +3. No? Okay, now ready. This is the most important moment. Remember, the solution for this kind of inequality consists in one algebra part, but one graphic part. See, I don't see in the solution the graphic part, I put 0 in the test. The graphic part for me is super important. There are different ways to do that. However, at least one way can you make a decision, because maybe you study with another teacher, okay, doing a little bit different like me. But remember, in 0 we have a hole. Don't forget the hole here. But in 3 and -3, 1, 2, 3, and 1, 2, and -3, we have partitions, because +3 and -3 are the critical values, CB, critical values. And you testing, using testing point, -4 is okay, -1 is okay, +1 is okay, and +4 is okay. And the testing you select was -4, -1, +1, and 4, or 5, or 6. It's not important the order. And the testing point, I listing -4, -1, +1, and +4. And you evaluate where? Well, you evaluate the factor, and the factor of the inequality part, no? The factor of the inequality part are x + 3 and x - 3. And you include one extra column, I call always total, okay, the column that finally I need to analyze the sign. I'm plugging in. This is the easy part. -4 here is negative, is minus, -4, -3 is -7, and double negative multiplication to be positive. So this is positive, this is negative, this is negative, this is positive, this is negative, and negative again. It's a coincidence. And this is positive, and this is positive, and this is positive. Do you understand very well where I come from, this positive and this negative? I don't need to explain in detail. Honestly.
Oh, you don't need to explain. No, you don't have to explain that on detail.
Okay, cool. So now I come back at the beginning. At the beginning I saw that my problem contained less than 0. Okay, it's equivalent to say to be negative. That the negative guy is true in our problem. This is true. And this is true. That the only testing point that passed the test was -1 and +1. 4 no, fail. And +4 and -4 fail. Both. So we focus in this. But be careful, this restriction. Non-zero que is a whole. Therefore, I suppose that my interval solution is this piece and this piece. And not include 3 and not include 4. Why no? Because you see equal sign here, maybe yes. But no equal sign does not include the end point and the gain. Therefore, the solution is parenthesis, 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 and parenthesis. Therefore, my final answer then is from -3 to 0 to interval union 0, 3. Like the option B in the handout. Question. What part you don't understand very well?
So we work out the question, and all we need is the line graph and the answer.
This is the procedure. Number 1, move everything to the left because right hand side must be 0. Step number 0. Step number 1. Secondly, factorization the left hand side. Now in this scenario, we discover that we have one factor that contain even exponent too. And so you make a decision. Oh, it's partial delete, or I know that you delete, but I don't understand very well if it's partial or it's totally. It's partial because my inequality is a strict inequality and not a combination. So see, you have equal sign here, then 0, yes, entonces you totally delete. And you convert this equation to this. Pero no, in this example, we have no equal sign. You partial delete, pero under the consideration, okay, in 0 we have a whole. Now we focus 100% in this inequality. It's easy. You put equal to 0, you find the critical value, you go do the graphic part. Graphic part now, important. You are doing the partition, remember again 0 we have a whole, you select testing point in each interval, you create the table to evaluate si it's true or false. You take the true, get the solution, highlight, on the line, and you write the final answer in elegant way. I would like your final answer is expressed always in this notation, interval notation. Any question? No?
No.
Excellent. Let's do one more. So I guarantee you that you have 2 questions with this of this kind of inequality. But no big deal. Very, very similar. Another number, of course, but very, very similar. May I erase?
Yes.
Okay. Erase. I did that? No, yes. Okay, let me go by 16. 16 is very interesting. Look. Is x to the 4th power minus 21, x to the 2nd power minus 100. Greater than 0. Well. Entonces now I don't need to create the right hand side 0 because already is 0. But I focus on the factorization. Let's do the factorization. Okay, it's not too hard. It's trinomial. Square root this guy is x squared. And you try the combination. I need to find 2 numbers that multiply each other. Give me 100. And somehow, when you add in subtraction, give me 21. I suppose it's 25 and 4, no? Suppose that you don't know, or in this moment you don't realize this combination, but you can apply quadratic formula, okay? But it's okay, to do fast, it's 25 and 4, because 25 times 4 is 100, and 25 minus 4 is 20. What sign? Negative and positive. Make sense? I finished? No, because I saw here another difference of a square. And remember, the sum of the square is always positive, it's primary. It's a primary. It's always positive. Now we can delete, totally delete. You say, Professor, but you explain me when it's equal, you totally delete. But it's different. Okay, it's different. This parabola, look, let me show you. Let me show you the parabola x squared plus 4 and the parabola x minus 4 squared or plus 4. It doesn't matter. If you want to put plus here, it's the same. This parabola is like that because 4 represents the y itself, and this parabola is like that 4. This parabola, be careful because this parabola is positive always. You can delete, but a partial delete because 0 may be a solution. But in this case, no. So you totally delete this. Chan. Because it's always positive. And remember, the control of the solution for the inequality is always the negative part. One guy that you discover that is always positive, you can delete in any inequality. But I finished the factorization. Of course, no. We have 2 more. We have different of a square. One more time. XX, 5, plus or minus. But this is super easy inequality that I enclose in the box because I pay my totally attention solving this inequality. Yeah, I don't care the ugly original inequality. Can nobody understand? Okay. To solve that, you temporarily, you convert to equation. And the solution is -5 and +5. And this is my critical value. And using this critical value, I do a partition of my all real number line. I put a line. It's my famous all real number line. I like to put 0 always, regardless that the 0 do not participate in this game. But it's okay, it's a reference to see. So 1, 2, 3, 4, 5. This is my first partition. And 1, 2, 3, 4, 5, -5 is my second partition. Yeah, I select testing point. One testing point excellent would be -6. 0. I love 0 because it's easy to evaluate, and +6. Yeah, I create a table to validate this testing point. Validate -6, 0, and 6 positive. And what factor I evaluate? I evaluate the factor x plus 5, x minus 5, and the column extra, que es the total. This is my table, que is no too long. And you evaluate 6 minus 6 plus 5 is -1, minus 6 and minus 5 together is -11, negative, and this is positive. Negative times negative, no? 0 is positive, this is negative, the answer is negative. And 6 is positive, it's 11. And 6 minus 5, 1, pero positive 1 is positive. So the important column is the last column. That is the reason they enclose and the circle the signs. Now I come back at the beginning. Yeah, I see that my problem is greater than 0. This is to be positive. It's positive here and here. Okay, because the only testing point that passed the test was this interval and this interval. Of course, this interval continues forever to -infinity and +infinity. But the endpoint, que es 5 and -5, not included inside the solution. Parenthesis, parenthesis. And this interval, no, because 0 failed, false. So what is my final answer of this inequality? Is from -infinity, comma -5, union +5, comma +5. Boom. Get the option D. Any question?
No questions.
It's easy. It's easy. It's mechanical. Of course, you need to memorize something. This is the thing in mathematics that the student maybe forgot. But if you create the sequence of the step. What is the sequence of step, guys? You take the original. You create right-hand side 0. Si es created, I appreciate so much your favor. Your factorization. So now this is the crucial moment in which you analyze if one factor is deleted or not, or partial, or totally. And you reduce your problem and easy inequality. You determine the critical value. Using the critical value, you make a partition in the real number line. You select totally arbitrary testing point inside each interval, que is representative of this interval. And now you create a table. In the table, you validate this testing point. And you take always the true, get the solution. No? And finally, you highlight in the number line. Any question? No problema. Okay.
No questions.
No. Let's change the flavor of this. Now we discussing another topic. But this is easy. Look, using the factor theorem, determine if this factor is given is belong or not to the polynomial. So my polynomial in the equation 17 is x cubic plus 2 x squared minus 6x plus a semicolon, and the factor that I need to investigate is x plus 1. So my recommendation, there are many ways to do this, but my recommendation is doing by synthetic division format. You copy the factors, okay, the factor is 1, 2, minus 6, 8, and you divide by this. How you divide? You copy, remember, in synthetic division, you don't need to copy the variable x. You copy 4, but on negative 4, opposite side. This is the detail. You bring down 1 without doing anything, a multiplication. 1 times negative 4 is negative 4. So you combine here is negative 2. Multiplication is negative, positive 8, sorry, because negative times negative is positive. We combine here is 2 positive, and 2 times negative 4 is negative 8. If the last column is 0, get the remainder, therefore you can affirm, yes, this factor belongs to this. This is one way. I want to explain another way, but I prefer that way because it's super easy. Super easy. Another way is, okay, so you don't remember very well synthetic division, you evaluate in negative 4. So this is the factor. Okay, proof using the factor theorem. But the 0 associated with that factor is negative 4. And you evaluate negative 4 inside the polynomial. So it's negative 4 to the cubic power plus 2 times negative 4 to the second power minus 6 negative 4 to the 1 power plus 8. Yeah, I put in the calculator one by one. This is negative 64. This is positive 32 because this is negative 4 squared is 16 positive, and 16 positive times 2 is 32. And negative 6 and negative 4 together is positive 24 plus 8. And when you combine everything, the answer is 0, exactly the same 0 of this. What way you prefer? Synthetic division or evaluate?
Synthetic.
Me too. Me too. That's easy. Entonces 18 and 19 is the same. Do you want to do or no? Yes or no? You let me know. 18 and 19. It's similar. It's the same idea. Do you want to do or no? It's a dog.
You go to 20. You can go to 20.
20. Go to 20. We skip 18 and 19.
Yes, we can skip.
Yes, since it's the same.
Put it, yeah, the same. Putting off the.
So in number 17, is the answer yes or no?
The answer is yes.
Okay. And it's only yes when you get a zero. For remainder.
Exactly. So
Okay.
yes, it's equivalent this statement. Si the answer is no, 0, es 20, es 200, es 2000, no. The answer is no.
Okay.
Okay, sure. Let's move into 20.
Yes, positive.
Okay, 20 now. 20 is the descarte rule. Let me recall this idea que es super easy. Let me show you. You have polynomial is given at the beginning, 20. F of x equal minus 6x to the 9 plus x to the 5th minus x squared plus 7. Okay. And remember the idea behind Descartes rule. Descartes rule. You need to find Descartes rule of signs. You have two quantities, P and M. Who is P? P represents the change of sign of the original polynomial. To say so, wow, look, this is negative and this is positive. One change of sign. This is positive, change to negative. Another change of sign. This is negative to positive. Another change of sign. Actually, P is 3. You see we have 3 change of sign. But the number of positive 0 It's a little bit different. It's you take that number, get 3, and subtracting that 3, or 3 minus 2 get 1, or 1 minus 2 get -1. No, -1 have no sense. You stop until you get positive number. So actually the answer is the number of real positive. This is a real positive. We have two possibilities, 3 or 1. Okay? Likewise, you take the original polynomial, but you make a reflection. And the reflection is for doing m part. Reflection is easy because when you replace x for -x, only change the term or the monomial que contain odd exponent. 9, 5, 2 no, is even, and 7 stay. Actually is 6 x to the 9 minus x to the 5th minus x to the second power stay the same plus 7. Do you understand very well that part or no?
Why does 7 stay the same?
7 is a constant. 7 do not depend of x. Entonces es a constant. 7 es considered like a degree 0. Because when the x is missing, it's because the exponent is 0, degree 0. Okay, entonces wait. This is my, well, I got it wrong. This is 6 x to the 9 minus x to the 5th minus x to the 2nd plus 7. This is my new polynomial after the reflection. So the thing I did was reflection. Now I investigate the number of the chain of sign of this new polynomial is called m. Is it positive, negative? 1. Is it negative, negative? No. Is it negative, positive? 1. Actually, n is equal to. Now the number of negative real is 2 or 0. Remember, you always subtracting 2. You take p or m minus 2 or minus 4 or minus 6. You subtract the even number until you stop. You know that you stop when you have negative number, and negative number have no sense. Entonces my answer is the option A, que es the degree of the polynomial original is 9. 9 comes from, for this exponent, degree 9. Cool. We have 2 or 0 positive. No. Positive 0. No, this is wrong. This is 3 or 1 positive 0 and 2 or 0 negative 0. It's 3 and 1 positive 0 and 2 or 0 negative. It's the option D. Make sense? Make sense or no? Option D. Make sense? Do you understand very well everything or no?
Can you explain it again? I'm sorry. I got a lost one. That
Okay.
P up to 3 positive. I just got it like go.
You are lost in the
So yeah, the partial one, like you just counting every from negative to positive. It's like you count 1, and from positive to negative you count 2, and then negative to positive. So you're counting every positive sign that you have on the polynomial when you switch them. That's what I got a little off.
But what part you want to explain again? Or another way?
Like the P that is 3.
Okay, good. Look, P represent the number of chain of sign in the original polynomial. I can see, look, this guy is negative. Now this guy is positive. So I mark using this, weight to indicate it's chain of sign. One chain of sign. And it's a positive negative, another chain of sign. And it's a negative positive, another. Actually, we have 3 chain of sign. It's a change of sign. Clear this idea?
Yes.
Cool. Now, the confusing part, at least for me, when I learned this the first time, We're going from 3 and 1. Okay, it's subtracting 2. You take 3. 3 is the first possibility. 3 minus 2 is the second possibility, que es 1. And 3 minus 4, que es negative 1, none. I discard this because it's negative number. So you're subtracting always even number, 2, 4, 6, until you have positive number. Is clear this idea? Likewise.
No, I don't understand why you resting 3 minus 2.
It's a rule.
Because...
It's a rule. Okay.
It's a rule. Okay, I'm
the
sorry.
I
just got like, what the two
was a mathematician here, and he present the rule. The only thing is we need to apply the rule. You understand the rule, and that's it.
Okay, so when you get the change of the sign, then you keep resting until you get a positive number.
Exactly.
That's how you have it. Okay, now it makes sense.
And likewise, and you understand the second part, when the reflection something, or no?
Yes, you get the reflection, and then you switch, like, you see.
Actually, when you are doing the reflection, you have another polynomial. No, entonces you apply the same, but this same que you apply now is valid for the negative. 0. I propose doing one more, eh?
Yes, please.
21st. Entonces maybe you understand, or we are doing together, or whatever. Okay. You copy? I can erase?
Yeah, you can erase.
21st, 21. No. Okay, 21. 21 say for x is equal 8 x to the 8 minus 4 x to the 7 plus x to the 6 minus 4x plus 8. Okay, remember the famous P and the famous M. P represent the chain of sign of the original polynomial. This guy is positive, this is negative, change the sign. It's a negative to positive, another chain of sign. Positive, negative, another chain of sign, and negative to positive, another chain of sign. Therefore, conclusion P is 4. But another different thing is amount of real positive 0. According to Descartes says you're subtracting. So 4 minus 2 is 2. 2 minus 2 is 0. We have 3 possibilities: 4, 2, or 0. Wait. Not good. P of 4. However, the positive is 4, 2, or 0. As you subtracting 2 one more time, is negative 2. We have 3 possibilities. Clear?
Yeah.
Okay. Now reflection to investigate the negative. Reflection is easy. The exponent even stays the same. The exponent odd, no. Change the sign. This is 6. This is plus 4x plus 8. And when you try to investigate the chain of sign against M, it's a positive. Oh, 0. No change the sign. Now it's obvious that the number of negative real 0 is 0. We have no. So the degree of this polynomial is 8. However, we investigate using the Descartes rule, okay, we have 4 or 2 or 0. Positive real. And we have non-negative real. And the rest could be maybe complex. This idea is clear?
Yeah. Okay. Thank you.
Do you want to do one more?
Wait, I have a question.
Go ahead.
So for the negative, if 8x was negative, so if it's a negative and a positive, that's 1, 0.
So
positive, positive, positive that leads.
Exactly. No change of sign. Zero change of sign.
Okay.
Okay, cool. So my question now is, in the 5 minutes that we have, do you want to do one more of the Descartes rule, or you understand very well Descartes rule?
Can I have one more?
Okay.
I'm sorry.
No, I obey your order. Okay, one more, no problema. The thing is, I want you get good grade in this test. Okay. Okay, delete. There you go. Suppose this 20 seconds. F of x is too long. Is x to the 6 plus 4 x to the 5th plus 4 x to the 4 power plus 3 x to the cubic power minus x squared minus 5x plus 4. Wow, what the hell? Too long. And remember the classical idea P and M. Let's do in P first. This is positive, 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 negative, negative, and positive. P is 2.
So it would be 2.
2 chain of sign. And now reflection. This is
But question, if you do P, forget the positive, you rest 2 minus 2, you get 0, so you will have two solutions, 2 and 0 as a positive?
Oh, okay. Yeah, I forgot to say that. Thank you. So the positive is 2 or 0. 2 possibilities. Let's move on to the M. I need to make it a reflection first. It's a minus 4x to the 5th power plus 4x to the 4th power minus 3x cubic minus x squared plus 5x plus 4. Do you understand this reflection or not? So the even exponent. It shouldn't be. The even exponent gets 6, 4, and 2, and 0 stay the same. Only change the sign, 5th power, 3rd power, and 1 power. Okay?
Yes.
Okay. Now I see investigate the sign. 1 chain of sign, 1 chain of sign, 1 chain of sign, no chain of sign, 1 chain of sign, no chain of sign. It's obvious the n is 4. 1, 2, 3, 4. Now the number of negative is 4, 2, or 0. Cool? Get the option D in our handout.
So basically, the odd numbers the odd denominator exponents will change the signs on the polynomial, not the even. Okay.
Do you understand why?
Yeah. Okay, thank you.
So clear the rule. I propose you do one more of the rational polynomials, rational theorem. Rational theorem, remember, find the potential 0. Okay. Let me try to find, for example, 23rd, 23. 23 is this page. So it is the solution 22nd, and 23 is listing the potential rational 0 of the polynomial function. Okay, and you don't need to verification. No, it's only list. That's it. So remember, it's a famous formula que es plus and minus P over Q. Do you remember that or no? And my polynomial is f of x is equal 6x to the 4th power plus 3x cubic minus 4x squared plus 2. Who is P and who is Q? P is this guy. P is 2. You decompose 2 and plus or minus 1 and plus or minus 2. It's the only possibility to break it down. This. And 6 is Q. This is Q. This is P. So P is the polynomial, the monomial que contain degree 0. And Q is the polynomial que contain higher degree. Okay, entonces plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6 because the number is 6. No, you decompose 6 and the factor que somehow multiply each other. Give me 6 is 6 and 1 and 2 and 3. And they find the combination. The list associated with this is list of potential zero, rational zero. You take the first number and the denominator is 1. So plus or minus 1 and plus or minus 2. Who is this? You divide this, divided by this, and divided by this. Makes sense, right? Makes sense or no?
Yeah.
And you take the second, que es 2, is 1/2. Don't forget always plus or minus. And 2 divided by 2 is 1, but 1/2 here. I don't need to repeat. It's important, no repetition in the list. Comma, 3, 1/3, and 2/3. Comma, I don't know. See, we have another que 1/6. I don't know. It's 2/6 is 1/3. 1/3 I have here. Finish my list. My list is plus or minus 1, plus or minus 2, plus or minus 1/3, plus or minus 1/2. Okay, the option B. I guess so. Look at that. Not necessarily in the same order. We did different, but it's the same list. It's the same element, no? Cool. 1/6, 1/3, 1/2, 2/3, 1 plus 1 whole number, and 2 whole number. Cool. Okay, guys. So I promise. I will send to you. Not now because I need to go to another place now. But in few minutes, I send that video plus 2 more videos that have the solution for the entire handout of the review package. Plus, I send also the hyperlink connecting with the My Desmos script, and you can see nice and clear the graphic of this. Cool? See you. Bye-bye.